All right, so this time we're going to do the same thing as before, but this time we have two quadratics. So it's really not going to change, really, theoretically, what we're doing. So again, I'm going to pick an equation and solve for y. So I'll just copy down the first one, but in the second one, I'm not going to copy it down exactly like I see it. Oops. I'm going to subtract over that x squared and that 2x. And then I'll go ahead and I'll take all this and I'll put it in for y over here. Alright, so we get 2x squared minus 5x minus, and then we'll go ahead and get everything over to the left side and consolidate as much as we can. So we should end up getting 3x squared minus 3x plus 2 equals 0. Right, so I'm not going to mess around with this. I'm going to jump right to the quadratic formula and see how that works for me. So we're going to do negative b plus or minus the square root b squared minus 4ac, and it's all over 2a, which of course is then going to become 9 minus, and this would be 12 times 2, which is 24, all over 6. I'm actually going to stop working because I can see ahead of time this is going to be negative, which means we're going to have an I in our answer. If we have an I in our answer, that means that there is no real solution. Right? Our job is to find the real solutions to this system. Well, I is not real, so we just stop working and we write no real solution. If we're doing elimination, again, I just like to have my y by itself, so I'm going to write negative y, and I'm going to subtract the 2x squared, add over the 5x, and keep the negative 2. I'm going to subtract over that x squared again, the 2x, and then I don't have anything else. And the y's already canceled, so that's nice. And then you'll find that we have the same thing pretty much as before. So even though this may look different than this, if you divide all of these by negative 1, you get that 3x squared minus 3x plus 2. So we will continue our work, of course, and then we know that this is going to become no real solution, so I'm not going to do the work over. All right, so we're going to get these ones set up, and for the second one, I'm just going to get the y by itself. And then to set up the elimination, again, nice to have the y's isolated, so we'll lose that 2x squared, we'll lose the 2, and we already have that negative 4x on the correct side. And then we'll lose the x squared, and all we have is a 2, so that's going to stay put. And we'll just kind of leave it like that. So I'm going to go ahead, I'm going to take this expression, I'm going to substitute it in for y, write it all out. We want everything to be equal to 0, so we'll distribute that negative real quick. While I'm at it, I'm going to add over that 4x so that everything does equal 0, and then we'll see if we can consolidate a little bit here. So this actually can be solved by factoring, which is really nice. So I can actually factor out an x, leaving me with 3x plus 4. And then I can set each parenthesis equal to 0, and that's going to give me x equals 0. And I'll end up getting negative 4/3 for this. So there's my two answers. And then I just need to go back and get my y. So if I put 0 in for x, I get 2. And if I put negative 4/3 in for x, I'm going to have negative 4/3 squared plus 2, which is going to become negative 16 over 9. So I could change this 2 into an 18 over 9, and add those together, I get 2/9. So these will be my two answers. And then if we're going to solve with elimination, this is already kind of set up for us to be successful. So we can just add the y and the negative y together to make 0. We get negative 3x squared. These make 0. We get our negative 4x. We can divide everything by negative 1, of course. And we literally have the same situation that we had over here. So I'm just going to go ahead and write what I will get eventually. So there's our two real solutions. All right, so ideally what we're going to do for this one is you get, if we were sitting in a normal class, normal school year, I would divvy the class up and say, all right, you choose. Do you want to use substitution or elimination? Doesn't matter to me. What we should probably all agree with is, regardless of what method you're going to use, it will probably be easier if you don't have extra parentheses in the problem. So I would FOIL this one out, personally, no matter which method I'm using to approach this problem. And then I'd also FOIL this one out, so I can get my negative x squared. I would get negative 3x and positive 9x, so that makes positive 6x and 27. FOIL this one out, we get x squared minus 4x plus 4. Do a little combining here, get our x squared minus 4x plus 1. So it looks like those are my two graphs, or my two equations, I should say. So you can choose if you want to do substitution or elimination. I will do both, and then if you pause the video, work yours out, then you can unpause and see how our answers compare. All right, so you can take a look here. I took one of these and substituted it for y and got this equation. Move everything to the left. I saw that I could divide everything by 2, make life a little easier, and this factored really nicely. So I got 2 and 3 for my x's. And of course, if you put 2 into either of these equations, you will get negative 3. And if you put 3 into either, you get negative 2. And then for the elimination, again, I just stacked them right on top of each other. So I just took this and basically swung it around so it matched the order I need. And then I chose to multiply the top row by negative 1. So it really just changes all the signs. And then I end up getting the same quadratic that I got over here. So whichever method you prefer, it's completely your call. Substitution seems to be the more popular one that kids go with, but they both get you the answer one way or another.